If you were to ask somebody that is new to 3D modeling what happens when you subdivide a model, their answer would be probably very simple. Well, your model gets smoothed. But there's a lot more to it behind the scenes. Yes, your model does get smooth. However, knowing how to take advantage of subdivision surfaces in general will go a very long way. So in this chapter, what we will be doing is we will be talking about exactly what makes up a subdivision surface and how not to run into any of the problems that subdivision surfaces do actually introduce. They are not all perfect. They have certain rules that they are defined by, and knowing those rules and exactly what happens will go a very long way. So let's get going. To use subdivision surfaces within Modo, the simplest way is to just simply press Tab on your keyboard. When you press Tab, it will toggle subdivision surfaces on or off. You can also double click on an object to select it and press Tab. This will subdivide only the portion that you want, or you can just select nothing and it will in fact treat everything as a whole, so you can subdivide everything. Now this only works for the currently selected layer, so if I just select the head here in my layer editor here and I press Tab, well, then my item or layer will be subdivided. Same thing if I press hammer. There you go. Now, there are other ways in which you can subdivide, and I'm just going to unsubdivide this for a sec. And that is if you go up to geometry, you will notice that there is a toggle subdivision, and there's also a toggle Catmull-Clark subdivision, and that is to use Shift Tab. So that's basically just the hotkey over there. So I could use, once again, Tab to go through this, or I could press Shift Tab to toggle a completely different algorithm for subdividing your models. Now there are some technical differences between them, but I will not be going into these in this video set because it really does go beyond the scope of this video. For the most part, just know that there are two different ways to subdivide. And also what you should know is that Catmull-Clark subdivision is really the algorithm that is most widely used in the visual effects industry. So if you're going to be using some, if you're going to be creating renders, you should probably stick to this. It is slightly better algorithm, especially when dealing with textures, creasing, and so on. Now, subdivision surfaces can also be found in another area within Modo, and that is to go down into polygon. So we are down in geometry, polygon, and if you go down to subdivide, you will get this editor, or this window. Now this window will provide you with several different ways of subdividing your model and several options. I'm going to click cancel and I'll show you the other place where it's actually put under. Now before, you went to geometry, polygon, and found subdivide. Now I would almost expect to see this under polygon, but it is in fact not there. You have to go into mesh edit instead, and in here under mesh edit you have subdivide, and you can in fact pick several ways to subdivide your model. So you have SDS subdivide, you have faceted, smooth, and then you have options. And options brings out the exact same window that we saw a few seconds ago. So next, let's talk about the actual subdivision surfaces. I popped into Photoshop for 1 second because I wanted to go over exactly what happens when you subdivide. I wanted to illustrate it instead of actually showing you on model because of the way Modo works. Now, what happens generally when subdividing is, let's just say you have a quad like this, and you have the vertices that are connected by the edges, and of course this inside is a polygon. Well, what happens when you subdivide? Well, what happens is every single edge that you have on a model will get subdivided into two edges. So now you have 4 new vertices. What used to be one edge is now 1, 2. At the same time, what happens is every single polygon on your model will also have now a point in the center. Also, these new vertices that you have here get joined up like this. So what used to be one polygon is now 1, 2, 3, 4 polygons. Now, it's kind of hard to tell from this example, but whenever you subdivide, every single one of your polygons will always be four-sided. So to illustrate this, if I go and create a triangle, and then select my color for my vertices, and it's not working for some reason, so let me just go to red. What happens here is, let's just say I have these vertices, these original vertices that are joining these edges. Well, if I have this edge here, this edge will then get subdivided into two, this edge will get subdivided into two, and same with this one. At the same time, the same rules that we had here apply to this object. So every single polygon will also have a point in the center. And if I just go back to my edge color, these new points will be connected up like this. Now what this means is that, I'm going to go back to green, is that every single polygon is 1, 2, 3, and 4. 1, 2, 3, 4. 1, 2, 3, 4 edges. So while this example was very clear, and subdividing one polygon into 4 obviously means that every single one of these polygons will always be four-sided, but even when you have a triangle and you subdivide it, it will also always be four-sided. The other thing you should know is that because of the fact that you went from one polygon to 4 polygons, if you have 1,000 polygons in your model and you end up subdividing this, you will end up with 4,000. Well, what happens when you subdivide 4,000? Well, you're going to end up with 16,000. And this is a very, very large jump, because every single time you subdivide, it's always 4 times more. So then 16,000 turns into 64,000. And, you know, the numbers just keep getting bigger and bigger and bigger. Now, these are still relatively small numbers, especially when you export into a package like ZBrush. But going from 1 million to 4 million, or from 4 to 16 is, you know, a very, very big jump. So always beware of how much you subdivide your models, and I think it should be fine. So let's move on back into Modo. So knowing what to expect, or at least if we go by our last example, where I took the square and I subdivided it in half, basically, you know, subdivisions always end up putting vertices down the center of every single edge on your model. At the same time, you have a new point down the center of each polygon, and the new points get connected up. So knowing this, I'm just going to select this polygon. I'm going to go to Mesh Edit, and I'm going to apply the static subdivision model. So SDS Subdivide over here. And once again, we get exactly what I was expecting. At the same time, the old points got smoothed over. In this case, the triangle, I already know what to expect. I'm going to get a new point here, a new point here, a new point here, and also down the center, and those new points will be connected. At the same time, this model, or this polygon, will also get smoothed over. So if I select it, it's exactly what I predicted. This is an n-gon, and the same thing's going to happen as what we had previously. It's also like you're also going to get quads, just like here and here. All the resulting polygons will always be quads, and every single one of these edges will get split, and then a new polygon or a new vertex will get put in the center, and those new points will be connected to the center point. So I'm going to select this, I'm going to subdivide, and as we can see, the model is becoming a lot more round. And at the same time, we have a nice pull here, which is usually something that you want to avoid, especially when using subdivision surfaces, or if you intend to do things like you know, sculpt, or if you're going to be deforming a mesh. Then the reason why you want to skip this is because of the fact that often you'll get pinching at pulls, especially if the geometry is changing. And yeah, that's pretty much why you want to get, you know, you want to avoid n-gons overall and pulls. Now here's the best reasons, or the best reason rather, why you would want to avoid n-gons. Now what's going to happen in this polygon is if we go by the rules that we explored earlier, every single edge is going to be split in half, so you're going to get a center point at every single edge. At the same time, this polygon will have a new vertex down the center. Except where exactly is this new point going to be? Well, where this point is going to be is at the center. So let me just select that and apply Subdivide. And what we get is a very unpredictable result, or rather predictable, just not, appealing in any way. Now, what ended up happening is this point was actually not put in the center of the polygon, or not inside the polygon. The center point got placed outside of the overall polygon shape. And this is one of the reasons why you want to avoid it. Now, we're going to explore this shape, or this case scenario, a little bit more once we get to this shape here. And of course, I'm going to be applying it in a much more practical kind of case. And again, you really want to avoid this. And all this really is that it's an n-gon, much like this one was, except the edges here, they go inside of the polygon past the center. So now it's much more difficult for the application to create a very appealing result. So let's move on to actual geometry. It's nice to be able to talk about very simple planes, but what happens when you have a full-out solid model that is solid from all angles, and the entire shape is enclosed? Well, if I go ahead and just double-click on this model, we already know what's going to happen to this square. I mean, the same thing's gonna happen to this square as happened to this one. So if I just double-click on this and press SDS Subdivide, if we look at this right here, it looks identical to this. Now it does look a little bit smaller, however, and of course the reason is because it's also moving a lot of these points, especially the original points, or even the new ones. It's moving them and deforming them to give a much smoother result all the way around. So all the points are now being moved. If you remember in this case study here, only the old points ended up moving and the new ones remained intact. In this case, of course, because of the fact that the new points were also connected to other geometry, they also got smoothed as well. And of course, they got smoothed along all sides. What's going to happen in this case, in this cylinder, is pretty much what we had here. So for every quad, it's going to get split like that. And of course, because of the fact that there's connected geometry on all sides, this polygon here is also going to pretty much look like this, except a much, I guess, a little bit more stretched. At the same time, we have an n-gon here, and that's going to look close to something like that. You're going to get a pole in the center, and you're going to get all these edges pointing to the new points. So let me just select that and go to Subdivide. And as you can see, that's exactly what happened. You have every single one of the quads that became these, more rounder shapes. And it's pretty much like this if I had stretched it. And at the center, you get something that's similar to this. Of course, there's a pole. And, but more or less, if I keep subdividing this shape and this shape, I should be getting very similar shapes between these two. But again, you really want to avoid poles because of the fact that if I keep working with poles and I export into ZBrush and I start smoothing and doing stuff like that, poles will not evaluate properly. At the same time, if I have a face and this face is deforming, poles will again show some kind of creasing and stuff like that. You usually want to avoid vertices that have more than 4 edges connected to them. So something like this is fine because I have 1, 2, 3, 4 edges connected to this. But because of the fact that I have 1, 2, 3, 4, 5, 6 edges connected to this, it's not going to be very pleasing. So let me just go ahead and just subdivide this once more. And as you can see, I guess this is a pretty bad example for now. But what if I was going to go into the sculpt tools? You know what, let me just subdivide it once more. So we have this shape, and for the most part it looks okay. In the center, however, you do see a pole in here. You see this star shape, and this is exactly what happens with poles. If I was going to start playing around with the sculpt tools and whatnot, or even smoothing, you'd always see this star shape, and this is exactly what you want to avoid. So you know what, I guess I don't even need my sculpt tools. But again, that's what happens with poles overall. Now, another thing I should explain here or show is what happens if I have a hole in a model. So all I did was I just selected this polygon, deleted the polygon, and now we have a hole in our geometry. Well, what I'm expecting that's going to happen is the enclosed geometry, so every polygon that's connected is going to get smoothed, and these edges will in fact get new vertices in the center of these edges, but it's only going to get smoothed along this edge or this plane. So you're going to get a much more circular shape, but the new points will not get brought inwards like this, like you have over here. These edges on the original box were pretty much all the way here, right? So now this, we've gone from here and they've been deformed over here. However, all of these edges will remain intact in this position here, and all the connected geometry will get smoothed over. So let me just select that and go to SDS Subdivide, and I'm going to do it twice. And as you can see, those edges have in fact remained on this plane, and all the connected geometry has been subdivided and smoothed over. In this case, what we expect is for this entire model to become a little bit more rounder. So between this, and this point, there's going to be a curve. So this really is going to be moved sort of like that. So there's going to be a nice curvature here. At the same time, between this, and this point, you're going to get a nice curve over here. And of course, between this, or this, and that, you're going to get a nice curve like that. You'll see it in a sec. At the same time, of course, same thing's going to happen on this plane. There's going to be some curvature here, and so on. So let me just select that, subdivide twice, and you get something like that. Now, you know what? Just for the sake of an example, let me just keep subdividing this and show you what happens at the poles. Now, granted, I've subdivided this model a lot, so it's actually difficult to see because poles often get hidden nicely, especially if you have a lot of geometry. But let me just go back one subdivision level. As you can see, for the most part, this model has been smoothed here, but poles don't really evaluate very well. Now, of course, we have a pole here, and all the connected geometry don't really display very well. And there's always that kind of sharp, sharpness that's being displayed around it. So that's pretty much why you want to avoid poles as much as possible. Now let's get into the more practical example. Usually when hard surface modelers create their geometry, especially ones that come from Lightwave and Modo, they end up working and creating examples close to what I'm going to show you here. So they end up doing something like this. And then they end up just making geometry like this. Now, this is okay if you look at it like that. The one thing I don't like about this is the fact that if you look at this polygon here, in the inside, you start seeing these weird edges or this weird kind of gradient happening inside of this. And all that is because what's happening with this polygon is that we've already talked about n-gons and what happens to them. Modo internally, behind the scenes, ends up triangulating your geometry. It can display quads just fine. It can display, triangles just fine. But as soon as you create n-gons and, Modo still, again, triangulates your geometry, so you end up getting normal problems like this between the, the shapes here. Now, this for now is okay, but what if I was going to subdivide this? Or what if I was actually going to make this a little bit more complex and add perhaps a hole internally here? So let me just create a cylinder. And let me bump that number up a little bit to make it rounder. Now I'm going to take this and I'm going to boolean this out. So I'm going to subtract, and now I have this result here. And I'm also going to grab all these vertices, or rather all these edges, and now I'm going to bevel out. So we have a result like this, but you know what? I want to make it smoother still. Like, let's just say I have a close-up, and I really want for all this to be nice and smooth, and for this polygon, for this big one here, to be perfectly flat. Well, if you give a model like this to a person to shade or texture your model or just render it, well, what happens when I'm going to subdivide this? We've already seen what happens with this example here, and this really is just a higher resolution version of this. So if I take this and I subdivide it, I get something like this. And this is exactly what you don't want for people to get. You don't want other artists to work with geometry like this. So if I was going to work in a preview mode where I press tab, you know, I get unpredictable results like this because Modo doesn't really know how to evaluate shapes like this. Polygons like this are very complex, and it ends up triangulating, but it ends up triangulating randomly. So in a case like this, what you really want to do is you want to terminate a lot of edges so that you end up creating examples of enclosed polygons and not polygons that have the center point of, basically, again, when you subdivide, you always have a center point, right? Like a new point put in the center of the polygon. You always want to make sure that the center could be put in a predictable place. So in this case, I would end up, I know for a fact that in this polygon here, the center is going to be somewhere here. For something like that, it's going to be put somewhere in the center here, and so on. But if we end up having a polygon here like that, and let's just say if I delete this edge, and if I connect this edge here, the center point of this polygon might actually be somewhere around here. So the subdivision overall would not work. And let me just subdivide that, and again, you kind of still see a very dirty subdivision, but here it's actually starting to look okay. So the more connections I make with my geometry, the better the result is going to become. And I'm just going to continue doing this until you end up seeing a result that is actually okay-ish. Now in this case, I have, you know, all this geometry here, and I really have nothing to connect it up to. So in this case, what you would want to do is you would want to perhaps subdivide this edge and then even bevel it, and maybe not with so many rounding levels, maybe just 1 or 2. This should actually suffice. So now I have enough to connect that up, and I could even do something like that. But again, you really want to get rid of any kind of geometry where you cannot predict where the center point will be. Now, this is actually not a very clean result. I actually don't like this result at all, but it's already a lot better, or at least I know what to expect when I press this, and as you can see, at least this side of the model is subdividing and it's looking okay. And all I would have to do is I would have to repeat what I did here on this side to this side. So if I was just going to go ahead and just delete this polygon for now and press subdivide, at least this looks a lot more respectable than what we had previously. This looks as if it actually subdivided and gave me a result that I can work with. So when I subdivide, when I press tab on my keyboard, or rather I use the Catmull-Clark subdivision because my tab button is actually linked to that. Again, this is a shape I could work with. So again, when you're working with n-gons, just beware of having geometry where you cannot tell where the center of the polygon will be.